Chapter 2, Computer Components. Almost all modern computers have the same basic design. They're made up of the same kinds of components. They all have processor, memory, secondary storage, input devices, output devices, communication devices, and a bus. And all of these components are mounted on or connected to the computer's motherboard. The processor is the component that actually performs the actions, that executes the commands that the computer does to do what we want the computer to do. Memory is the computer component where data, information, programs are stored for immediate use. Memory, primary storage, random access memory, RAM, is typically volatile. That means when you turn off the computer, the contents of RAM are gone, disappear. Secondary storage is the non-volatile storage where information is stored that you don't want to lose for that you will want to use for a later session. Some of the most common kinds of secondary storage are solid-state drives, relatively recent development, solid-state devices using integrated circuits for storage of data, taking over in place of what had been dominant for many years, the hard disk drive, which uses a rigid rotating disk with magnetic materials embedded on it. Optical storage devices store data by putting marks in a pattern on a plate and retrieving data by shining a thin laser light onto them and determining whether it is reflected or absorbed. Flash drives, similar to solid state drives, but have their own integrated USB interface, which means they can be moved from one computer to another relatively easily, whereas the solid state and hard disk drives are built into the computer and are not transferable. Input devices are components that allow us to move information or data into computer memory. The most common input devices are keyboards and mouse. Output devices are used to transfer data information from in the computer to the outside world, to the users, or to other computing devices. The most common output devices are monitors and printers. Communications devices are devices that facilitate communication with other devices. Communication devices include network interface controllers, wireless communications devices, Bluetooth interface controllers, Ethernet ports, modems. A bus is a component that moves data from one place in the computer to another in the same computer. In most systems, these components are going to be mounted on or connected to a motherboard. A motherboard, system board, is a circuit board, and electronic components are attached to it or built into it. The central processing unit, or CPU, is the component that interprets and carries out the instructions that result in the computer doing what we want it to do. A CPU has two subdivisions, control unit and arithmetic logic unit. The control unit directs and coordinates the operations of the computer, and the ALU performs the arithmetic operations on the data supplied by the control unit. The processor, CPU, relies on a crystal circuit called the clock generator to control timing of the computer operations. In an effort to get better performance, some users change the system clocks to run at higher speeds. This is called overclocking. It does result in a system running faster, but it can cause data errors. Quite possibly the CPU reading the content of a cell before it has stabilized. So we get the wrong value when reading it. The most common problem with overclocking, though, is overheating. If your CPU is running at a higher speed than it's designed for, then it's going to be using more energy than designed for and producing more heat than the system is designed to handle. The term memory refers to semiconductor memory, addressable semiconductor memory, and most of this kind of memory is organized into groups of cells, each cell storing or representing one bit of information. It can be represented as a 0 or a 1. Cells in computer memory are generally arranged in groups of 8 cells called bytes, because one bit of information is just not very much. Combinations of cells can represent much more complex things in memory. Each byte, each group of 8 cells, is assigned an address, a number that identifies that byte and allows the computer to reference or modify the contents of that byte. The contents of memory represent information. And since an individual cell can only store one bit of information, a 0 or a 1, it's necessary to use groups of cells if we're going to be dealing with information of any complexity. How long it takes for a processor to reference a memory cell is pretty much independent of where that cell is located in memory. That's why the memory is called random access memory. That makes this primary memory different from the other kinds of storage media, hard disks, CDs, DVDs, and so on. Those kinds of media, the time that it takes to read and or write data items depends a lot on where they happen to be located on the storage. The time difference is due to mechanical considerations, how fast it's rotating, how long it takes to move an arm from one location to another. Now, there are two distinct kinds of primary memory: random access memory, RAM, and read only memory, ROM. The computer can write to make changes in RAM, but cannot write to locations in ROM. That's why it's called read only. ROM is implemented using non-volatile kinds of memory. Data in RAM and ROM can be read from, but only possible to write to cells in RAM. RAM is normally associated with volatile kinds of memory. Access to locations in RAM is generally a lot faster than locations in ROM. Some kinds of RAM are faster than others. Faster RAM tends to be more expensive, tends to use more power, and produces more heat. Computer manufacturers design systems with relatively cheap memory for most of the RAM, but they include a small amount of more expensive high-speed circuitry called cache memory. A system will store information more likely to be accessed frequently in cache memory. Secondary storage, external memory, auxiliary storage, differs from primary storage in that it's not directly accessible by the CPU. The computer normally uses I/O channels to access the secondary storage, transfers the data using buffers, intermediate areas in primary storage. Secondary storage is non-volatile. It does not lose data when the device is powered down, unlike primary storage. Secondary storage is also a lot less expensive, 2 orders of magnitude less expensive than primary. But of course, the access is slower, milliseconds instead of nanoseconds. Modern computer systems typically have a lot more secondary storage than primary storage, a couple of orders of magnitude more. Hard disk drives are a common secondary storage medium, although solid state drives, SSDs, are becoming more and more common. The time it takes to access a byte on disk is in milliseconds. The time to access the byte or location in RAM is nanoseconds. Optical storage, CD and DVD, are even slower than hard disk drives. When the disk is read-write head reaches the proper position and the data of interest rotates under the read-write head, then the rest of the data on the same track is relatively fast compared to getting the read-write head into the right position and the initial byte being getting to the read-write head. To reduce the time, access time, seek time, the time that it takes to get the read-write head in the proper position, and rotational latency, the time it takes before the data gets under the head. In order to reduce access time, data is read to or read from the hard disk in large contiguous blocks so that once the read-write head is in position and the initial byte reaches the read-write head, the rest of the bytes come fairly fast. Of course, users have to have some way to get information into their computers for the computers to work on. To facilitate this, the computers have to have some kinds of input devices for the users to input information. Traditional input devices include keyboards, mouse, scanners. More recently, touchscreens and cameras are becoming even more widely used. The keyboard is a typewriter style device. It uses buttons or keys to act as mechanical levers or electronic switches. The mouse is a pointing device. It detects motion on a surface. The motion is typically used to move a pointer or cursor on the display. They use the mouse for interaction with a graphical user interface. The pointer, the cursor, identifies the place where the actions of the user are going to take place. Typically, the mouse has two buttons or three. That's where the user can click one or another of the buttons to interact with the graphical user interface. A scanner is a device that scans pictures, print documents, handwriting, or physical objects. It creates digital images of these. Now, a touch screen is a screen that's sensitive to where the user presses on it. The user can give his input by touching the screen with his fingers or with a stylus. The touchscreen enables the user to interact directly with what's being displayed rather than using some kind of intermediate device. Touchscreens are commonly used in game consoles, personal computers, tablet computers, and smartphones. The popularity of smartphones and tablets and other kinds of appliances is driving an increasing demand for touchscreens on all kinds of portable electronics. Touchscreens can be found in the medical field and in heavy industry, as well as in automatic teller machines and kiosks. Kiosks get used in places like museums where keyboards and mouse systems aren't intuitive enough, fast enough, or good enough for interaction by untrained personnel. Digital cameras create digital images in a digital format. These images can be stored on portable medium, flash drives, and so forth, and this portable medium can be used to transfer the images to a computer or storage unit. Many computers, and especially smartphones and tablets, come with digital cameras built in. With the built in cameras, the digital images get automatically placed in the storage of the computing unit. And from there, they can be accessed for processing or transferred to other devices using the communication software. The widespread use of voice controlled systems, Siri, Cortana, Google Assistant, Alexa, is made possible by major improvements in natural language processing software And of course, computing devices that make use of these have to have sound detection devices, microphones. Now, of course, if the computing device is a smartphone, it's pretty obvious that it has to have a sound detection device built in. Now, an output device is a piece of equipment used to communicate the results of your data processing, your information, to users. It converts the digital electronic information into some kind of a form that a human can deal with, can read, can hear, can feel, somehow find out, get a sense of what the results of the data processing was. Well, there are two basic kinds of output devices, devices that produce output that users can see, and those that produce output that users can hear. There are other kinds, produce things you can feel, but those are much less common than visual or audio. The audio output devices, in turn, can be divided into devices that broadcast to the public, to multiple people can hear, and private, those that only one person can hear. Computer speakers are output devices that your computer uses to produce sounds, and they're generally used for public audio output. Anybody in the immediate area can hear the sound that they put out. Headphones are low volume speakers that are placed close to or even inside the ears. They produce low volume sounds, so only the user can hear them. They might be for reasons of privacy or simply to not to disturb others in a public area. Headphones can generally produce sounds of higher fidelity than do speakers. Part of the reason is that they don't have to correct for room conditions. They're directly into the ears. They're useful for video games. They allow the players to judge the position of sound off-screen sound source. Sound footsteps coming toward one or going away, emulating gunfire from a given position in the game. There are two general classes of visual display devices, those that produce soft copy and those that produce hard copy. Soft copy is temporary, like the image on a computer screen. Hard copy is more or less permanent in a physical form, like printed on paper. The term monitor refers to a display screen for video images, also referred to as video display terminals, video display units. The earliest computer monitors were constructed like the early TVs, cathode ray tubes with fluorescent screens. Today, most monitors use flat panel display technology, and flexible OLED technology is becoming more and more common. Flat panel technology encompasses a growing number of display technologies. They are lighter and thinner than the cathode ray tube, and most of them are liquid crystal LCD technologies. Very large displays tend to use plasma technology. OLED, organic light emitting diode, is a light emitting diode that can be embedded on a flexible plastic. They're used to create displays on flexible materials for use in applications like wearable devices and on curved surfaces and flexible surfaces for surfaces that change shape. Projectors or image projectors project images or moving images onto surfaces like white walls or projection screens. Early projectors created their images by shining a light through a lens, but the newer projectors can project their images directly using lasers. The very latest are handheld projectors. Many of the handheld models don't produce very bright images, and they can be hard to see if there's any ambient light. A printer is an output device that prints its output on paper or sometimes on other kinds of physical media. The most common kinds of printer are laser and inkjet. Laser printers are typically black and white, although more expensive laser printers can print in color. And inkjet printers typically print in color. Many computers come with communications devices installed. The most common kind of communication device is a network interface controller, or NIC. The NIC is a hardware component that connects the computer to a network. Most of the modern computers have their network interfaces built into the motherboard. Most modern laptops and lots of desktops, most modern laptops come with hardware built in for wireless communication. Wireless hardware on a desktop computer eliminates the need to run network cable from the router to the computer. Many of the desktops also have built-in wireless hardware. The wireless hardware can give your laptop or your desktop the capability of communicating wirelessly, obviously, with other computers, either directly or through a router. Bluetooth is a wireless technology. It's generally included in smartphones and laptops, as well as most desktop computers. It allows computers to communicate with other Bluetooth enabled devices. The Ethernet port is another popular communication device that comes standard in many personal computers, although many of the more recent laptop manufacturers have opted to remove the Ethernet port, produce their laptops without an Ethernet port, rely on the wireless communication for external communication. Modem is a network hardware device that supports communication over existing communication structures, usually telephone lines or cable TV connection. The modem encodes, modulates digital information to be transmitted using a carrier wave and then to be decoded by another modem, demodulated on the receiving unit. The most common form right now is the cable modem that allows access to high-speed internet over a cable television network. The earliest modems used existing telephone connections. They transmit and detect sounds on the telephone line that are combinations of frequencies. It used to be thought that 9600 bit per second was the best that could be done with standard telephone lines. But in the late 1980s, they developed techniques that were improved, that were better, and got better bandwidth on existing telephone lines. Most common one of these is asymmetric digital subscriber loop, ADSL, or most commonly DSL. DSL uses different wavelengths, different bandwidths for uploading and downloading. The DSL connections use the traditional standard existing telephone lines. It's cheaper and easier to use the existing lines than it is to install high bandwidth lines, fiber optic cable. Telephone lines were pressured into using DSL because they were starting to lose clients to cable companies. The demand for high bandwidth applications such as video and file sharing contributed to the demand for high bandwidth communication and popularized the DSL technology. A bus is a physical connection for transmitting data from one place in the computer to another. Computers have several different kinds of buses for different kinds of data. They have buses to transmit data. They have buses to control addresses for data transmission, and there's a universal serial bus, a USB,